back in old days, when internet was made public, since it was mainly a military venture led by DARPA and ARPA, it was hardly a requirement that modern day websites kind of content would be used. Back in those days, the only requirement was to send a request for a simple HTML page with just one frame and only text written on it, and then it was serviced. So the job was so simple because the requirements were very simple. So back in those old days, non-persistent HTTP connection was good enough. In this module, we shall see what is non-persistence with a focus on simulating it to a formal model. And then we'd look at the ways to quantify non-persistence. In order to determine the fundamental behavior of non-persistent HTTP, let's look at this scenario once more. Here we see that when a client is interested in sending a request for an object to the server, it opens TCP connection, as we understand. But if the total number of objects at the destination server are many, TCP handshaking, that is, connection establishment and connection tearing down, are performed every time. Naturally, in modern times, this thing does not make sense. But as I said earlier, that in old times, there was no requirement as such. So non-persistent was pretty much acceptable. So if we are using non-persistent HTTP, and if we have more than one object, so one thing is for sure, that TCP handshaking, both for connection establishment and connection tearing down, is going to take place every time for every object. So it requires at least 2 RTTs, 2 round trip times per object. And the total time it takes for downloading n objects from a remote location are given by n times 2 RTT plus n times the transmission time, because the transmission time of each object is going to be, of course, different. Although we see that this is a waste of resources, but this is what it was, and that is why non-persistence is not used anymore. You can also appreciate that in a multi-hop network where the client and server are spaced many hops away, this overall time calculation goes only worse. Because in a real-world network, the queuing, scheduling, packet loss at the intermediate routers is also going to happen.